Hi, today we're going over 6.1 equivalent rational expressions. So remember that from chapter 1, a rational number is a number that terminates or have a repeating pattern. They can also always be represented by fractions. So for example, 0.8 is the same as 4 over 5. If we have 0.111 repeating, that is 1 over 9. Now, pi is considered to be irrational because the decimal continues on, and there is no pattern to the decimal. Now, a rational expression can be written in the form a over b, where we have a restriction b cannot equal 0 because we cannot divide by 0. A rational expression is the quotient, which is a division of two polynomials. Just a reminder that polynomials do not contain radicals, so do not have square roots, cube roots, fourth roots, or variables as exponents. So we don't have, for example, 3 to the power of x. Now, some examples of what rational expressions are is 3x over 5 plus x, 2 over x squared plus 3x minus 5, 5x over x squared over 2. These would all be rational expressions. So essentially we have something in numerator, something in the denominator, and we have variables. So the first thing we'll talk about is equivalent rational expressions. To find an equivalent expression, we reduce to lower terms or multiply the numerator and denominator by the same term or terms. So find an equivalent rational expression to 3x squared over 5y squared. Now, when you have a question like this, there is literally an infinite amount of possible answers because, like I said, to get something that's equivalent, all we have to do is multiply the numerator and denominator by the same value. And it can be any value we want or any variable we want. So if I wanted to multiply them by, let's say, 6, that gives me 18x squared over 30y, and they are equivalent because this can reduce back down to this. More commonly, though, we'll be asked to simplify a rational expression, in which case we want to reduce it to lowest terms. So we'll want to simplify, and we have 2x squared y z to 4 over 4x y squared z to 4. So first off, we'll reduce the numbers. So 2 over 4 reduces to 1 over 2. So we'll just put a 2 in our denominator for now. If we need to later, we'll put a 1 in our numerator. Then we've got x squared divided by x. So x squared divided by x is x, so we'll put that in our numerator. Then we have got y divided by y squared. So if you remember, with division, with exponents, if we're dividing, that is the same as subtracting exponents. So if we have y, that's y to 1, so 1 minus 2 would be -1. And instead of having y to -1 up here, we just move y down here to make it positive. And then z to 4 over z to 4 are identical terms, so they cancel out. So we'd have x over 2y. Here's another one to simplify. 25a squared b to 4 c to -1 over 35a b cubed c cubed. So both of these are divisible by 5, so we'll do that first. We have 5 over 7. Then we've got a squared divided by a, so that's a. And then b to 4 divided by b cubed, so that's b. And then c to -1 divided by c cubed, so that would be c to -1 minus 3, so that's c to -4. To make it a positive exponent, it goes in our denominator and is c to the power of 4. Non-permissible values is another way of saying restrictions. Now, these will only occur if we have variables in our denominator, and they're stated from our original expression, not our simplified one. To find our non-permissible values, what we want to do is factor out the denominator or factor the denominator, and then figure out what values of a variable make the denominator equal to 0. So for example, find the non-permissible values of, and we have 1 over x plus 3, and we also have 1 over x squared plus 7x plus 10. Now this first one, we can't really factor. We can come up with our non-permissibles from this flow because we know if we put negatively in for x, that's going to give us 0 in our denominator. So therefore, non-permissible would be x cannot equal -3. When we have something like a quadratic in our denominator, we are going to have to factor it. So factoring this, we get x plus 5 and x plus 2. So for looking at this, I have non-permissibles of -5 and -2 because either of those make our denominator equal 0. Okay, so now we'll combine a couple things. So we'll simplify and state any non-permissible values. So we've got x squared minus 10x plus 24 over x squared minus 12x plus 36. So our first step would be to factor the numerator and the denominator. So factoring this, we're looking for two things that multiply to positive 24, add to -10. So that would be -6 and -4. In our denominator, we're looking for two things that multiply to positive 36, add to -12. So that'd be x minus 6 and x minus 6. Now, before canceling things out, we look at our non-permissibles. In this case, they're the same because the binomials are identical. So we have x cannot equal 6. And simplifying these, we cancel those out. So our simplified form is x minus 4 over x minus 6. So practice for a section can be found on page 525.